Hello everyone and thank you for peeping into this video. My name is Gautam Bharadwaj and I'm currently working as a space systems engineer in Thales Alenia Space UK. I know, cool stuff. Uh, the reason that I wanted to make this video is because I wanted to share to Indian students who are currently in India about the prospects of aerospace engineering in Europe from two perspectives. One is in terms of education, so masters and stuff like that, and then second is what are the working opportunities for Indians. Um, the reason that I specifically wanted to make a presentation about this topic is that normally the aerospace engineering industry, although is booming, can be a bit difficult to navigate and find opportunities for. So it's always good that you know in advance what you're jumping into. So, um, this is just a quick agenda. I'm going to share who I am and what I do, talk about my bachelor's and master's experience, and then I'll go on to what I think are currently, let's say, exciting domains and fields of interest in the aerospace engineering sector. Okay, so I'm currently a space systems engineer and I work in Thales Alenia Space, which is a company that manufactures telecommunication satellites and also does a lot of other space missions. Space missions also. Check them out. They are a French-based company with branches in France, in Italy, in Spain, in the UK, and few others. So it's a company to take a look at. I will talk about what systems engineering is later on because that is something that they do not teach in universities back in India, which is something I explored while I was in France. So I completed my master's degree in 2022 from France. So I did my master's degree from 2020 to 2022, after which I got a job in the UK in Thales Alenia Space. So I'm pretty young in my career, and because I'm pretty young, I kind of understand um, the overall process. Let's say, from doing your bachelor degree in India, then doing your master's degree in Europe, and then finding working opportunities and taking it forward. So yeah, I think I'm in a I'm in a good position to share the information with all of you, which I'm very excited about. Um, so I'm very passionate about mentoring and helping a lot of young students. I have mentored a lot of students across India on various space projects, guided them on higher education opportunities, etc. I had also worked as a mentor for the Society for Space Education Research and Development for about 1.5 years. So outreach and reaching out to people is very something that I'm very passionate about. If you guys want to know anything from a personal perspective or if you want individual attention, just reach me out to LinkedIn and I'm very happy to have a chat with you all. So let's talk about my undergrad experience. So normally the mindset that people put you in when you go and do your bachelor degree is you need to choose what you want to specialize in. एक stream choose कर दो, choose a stream that you want to specialize in, build that up based upon your internships and whatever projects, etc., and then you can sell it at the end of your bachelor degree. What I did was I was not able to find what specific aspect of aerospace engineering I was very passionate about. So what I did was I tried to be a bit unconventional. I spread my roots out everywhere. So I worked on drones. I worked on RC aircraft, which means I worked on aero modeling. Um, I did a lot of robotics, machine learning, Internet of Things, and did small projects related to that. Um, and the reason I did that was because I thought that these were hot topics that are currently like in the current, so in, let's say, in the current job sector and even in general in society. I felt like these are things that I should be aware of and I should know of. So I did some work related to that. Then during my third year of my bachelor degree, that's the time where we start to find internships and stuff. So I did a I did an internship in IISc Bangalore. specializing in computational fluid dynamics, where I worked on, let's say, here tukda projects on airfoils and wings, subsonic and supersonic. And then after that, I was awarded a fellowship at IIT Madras. So this is a yearly fellowship that IIT Madras, IIT Bombay, and a few other IITs organize. And I did my fellowship in IIT Madras in structures, specifically in composites and contact mechanics. Okay, so you can see that my undergrad experience has been very, very diverse. Um, what I took care of during my undergrad was to focus on co-curricular activities. So whether it is, public speaking or whatever, taking part in clubs and activities. And the reason for that is not only just to have fun, but then when you go abroad, when you're applying for a master's degree abroad, the co-curricular activities um, is what people base your, let's say, your personality and your soft abilities on. So universities do appreciate a very good CV in terms of content and your internships and your projects, but then co-curriculars also matter. Okay. So my takeaway from my undergrad experience, if you can see in the bottom of the slide, was that if you are unsure about which domain you want to specialize in aerospace engineering, or if you're coming from, say, a mechanical or an electronic background, diversify, try out different things, gain as much experience as possible, and in that process you will kind of figure out where you want to go. Also involve yourself in non-academic endeavors. And the last point, very very important, especially from an Indian perspective, सभी लोग बोलेंगे कि CGPA is important, GPA is important, so on and so forth. Try to take the importance away from that and try to focus on fundamental understanding. Okay, the GPA will come. I can speak for myself. I followed this during my undergrad experience and I ended up with a GPA of 9.85. Okay, so if I can do it while following this kind of method of thinking, I'm sure all of you can. So I finished my bachelor's degree in aerospace engineering, and towards the end of my bachelor's degrees, I realized that it was difficult for an aerospace engineer to find a job in India. Okay, so this was in 2019. So companies like, say, Agnikul, Skyroot, Pixel, I'm talking about space companies, and then a lot of drone and aircraft, the small aircraft companies were not yet well developed. So there were not a lot of opportunities for me then. Even now, I would say that's almost similarly the case, because they rarely take in entry level people. So you need some experience to get a job over there. So what I did was I decided to apply for my master's. My initial target was to go to US. Okay, I did not have an intention of going to Europe. Why? Because US is the center of aerospace engineering. There are so many things, right? US is extremely far ahead compared to the rest of the world in aerospace engineering. So I applied to different universities. I applied to MIT, I applied to University of Michigan, Georgia Tech, Purdue. These are all, let's say, cream of the crop universities in aerospace engineering in the US. And then in Europe, I applied to two universities. One is TU Delft, specializing in wind energy, and ISAE Supero, which is the university based in France. What happened is I ended up receiving the an MBDA scholarship. I ended up receiving a scholarship to go do my masters in this university called ISAE Supero, which I honestly did not know a lot about before applying. uh, the domain of specialization was to be chosen only in the second semester. So the first semester was a general course. Second semester you chose what you're going to specialize in, and I decided to specialize in systems and controls, simply because I thought that it was a more generic specialization, so I could cross into many different domains. Uh, and it was then that I realized, after doing some more research, that Europe is actually more open in terms of job opportunities. So, if you speak to your seniors who have gone to the US and who have pursued aerospace engineering, um, and if you talk to other people, you will see that most of the aerospace engineering jobs are, let's say, gatekept by something called as ITAR. Okay, so ITAR is a trade regulation that is imposed by the US government on almost all aerospace companies. And this ITAR regulation prevents aerospace companies from recruiting non-US people. So you either need to be a US citizen or you need to hold a green card in order to work for most aerospace companies. Now, some companies may not have this caveat, right? The companies that do not have this caveat will be those companies that are not yet working with the US Department of Defense. But then the US Department of Defense works with almost all major companies, you know. And in the space industry, if there are any startups, they automatically get funded by NASA and the government, and automatically you are obliged to become to follow those rules. Europe, on the other hand, is much more flexible. So you have opportunities in aeronautics. In fact, Airbus is headquartered in Toulouse, in France, and a lot of the aeronautical industry is completely based in France and Germany. Wind energy is based in Netherlands and Denmark, and then you have a thriving space industry also. So you have a good mixture of startup, private, etc., and the restrictions are not as severe as in the US. So in hindsight, Europe made more sense to me made more sense to me because I wanted to immediately find a job after doing my masters. But it's important to be aware that if you're planning to do a PhD, the US is probably more ideal simply because of the better quality of research. You can spread your wings wider. There is more funding for teaching based jobs over there. So, if you're planning to do a PhD and get into academia, the US is probably a better place. But if you want to enter the industry, Europe is probably better. Another thing to keep aware of is a European PhD. So, a PhD from any European university will take a maximum of 3 years, and I mean a maximum. While in US it can take anywhere between 4.5, 5 years to 6, 7 years to do a PhD. So there is a huge difference in terms of time commitment when it comes to your PhD too. So all of this has to be taken into account. And finally, France and Europe in general, there are much more scholarship opportunities that are available to students. US is a bit more restrictive and the fees is much more expensive. So people who are not, let's say, very well off, you'll have to take huge loans. And so Europe and France may be a bit more lucrative. Not lucrative, I'm sorry. They may be a bit more, let's say, a more practical choice in that aspect. So what kind of master's opportunities did I find in Europe specific to aerospace engineering? So, aerospace industry is prevalent in UK, France, Germany, Netherlands, Sweden, even some in Italy, Spain, etc. But these are the main ones, especially aeronautics. I put the UK in red because UK is not part of the European Union, but they are part of Europe. Okay. So as part of aerospace engineering, something people don't think a lot about is wind energy. Okay, wind energy is a extremely practical application of aerodynamics, computational fluid dynamics, etc., which is worth thinking about if you're into that domain. And Netherlands, Denmark, and Finland are pioneers of wind energy, especially Netherlands and Denmark. Um, There are both 2 year and 1 year degrees that are present in Europe. Most of the 1 year degrees, 1 year master degrees, you will find in the UK, whereas the rest of Europe usually has a 2 year master's degree. So, regardless of whether you want to study, let's say, aeronautics or space, the list that I've provided are good universities where you could think about doing your masters in Europe. So, the starting one is TU Delft, which is based in Netherlands. Huge aerospace department, good research background, strongly research oriented, very good alumni. The second is Isai Supero, where I studied, which has extremely strong ties to the industry in both aeronautics and space domain. So in Isai Supero, a lot of the courses that are taught to students are not taught by professors but are taught by people from the industry. So you can imagine that you're getting, let's say, the latest and updated information from the industry when you study there, which is a plus, especially if you want to integrate into the industry later on. Then you have ETH Zurich in Switzerland, specializing in controls and robotics. They do a lot of good work with drones and automated systems. Imperial College in London, KTH in Sweden, that is good for structures and aerodynamics, and then TU Munich in Germany, which is a very well known university with good reputation. Sorry, I'm going back. Oops, I'm sorry. Yeah. So, what are the things to keep in mind when you are applying to do your masters in Europe or or abroad in general? Okay. First thing to think about is what is the intention of your masters. So, do you want to do your masters and get a job? Do you want to do your masters followed with a PhD? Do you want to do your masters for research? Do you want to do your masters to start your own company, etc.? And each of those choices that you make will influence where you want to go and what you want to do, which is important, which flows down to the next point, which means if you're working, which domain do you go, and more importantly, is the market there for it right now? So a simple example for this is, for example, CNC cutting, right? About 10 to 15 years ago, the mechanical engineering domain in the mechanical engineering domain, CNC coding and CNC software was like a hot skill at that point of time, and everyone was trying to learn it to become more, let's say, um, to basically boost up their profile. But then now CNC has become so commonplace that it is no longer a skill of value anymore. So certain skills become outdated and get replaced with new ones, and it's important to know whether that thing that you're doing or learning is relevant to the market today. Okay, so based upon what your purpose is, how renowned the university is may not matter so much. Okay, so for example, TU Delft it's a world renowned university. However, since they are strongly research oriented and Netherlands does not have a very strong aerospace industry, finding a job can be a little difficult. On the other hand, Isai Supero, where I did my masters in France, it's not extremely well renowned. It is gaining popularity for sure. Um However, it's not, let's say, as well known as TU Delft. But since there are close ties to the industries, working opportunities become a lot more common. So it really depends on uh, what your purpose is. And automatically, better industrial ties means better alumni, and the thing just cascades on and on. Another thing to keep in mind, as I mentioned before, is what universities are the places where I could get scholarships, I could get grants, I can get part-time work, I can get, let's say, a research grant, you know, teaching assistantships, research assistantships, etc. So keep all of that in mind. So I'm let me focus specifically on France a little bit. So the study and work permit system in France allows you to work 20 hours a week while studying, which means people who want to work part-time can work part-time. This is usually the case in the rest of Europe, so you can use this kind of as a template. Okay. For those who are interested in traveling, if you get a student visa in France or Germany, etc., you can visit all the countries in the European Union. This student visa is valid for 2 years, after which you are provided 2 years to find a job in France. So you finish your masters, 2 years, you are allowed to take 2 years in order to find a job, which is usually more than enough for anyone to find a job in France normally. Okay. What happens is, even if people can't find a job, say 3 4 months after their masters, they go back to India and then they continue applying for jobs in France so that they can save up on money, but then they have the visa that makes them eligible for jobs anyway, and they try to do some side hustle or gain some experience in India also. So a lot of options available, and it leaves a lot of options open. And after staying in France for 5 years, you're eligible to apply for a citizenship, which is great. 5 years is not a long period of time when compared to the US, where getting a green card has become so ridiculously difficult. This is much better. Again, fair warning: this information is not because I think France is the best place, but then I have personal experience with France, and that's why I'm sharing it with you guys. So, what are uh, the Europe working opportunities? So, if you want to work in mainland Europe, which means France, Germany, especially France and Germany, which has the majority of the aerospace industry, you will have to learn the native language at some point, which means you'll have to learn French or you'll have to learn German. Okay. E- even if the actual job does not require you to use English, sorry, does not require to use French or German, just for general socializing or for basic housekeeping and general maintenance of your life, it becomes essential to learn these languages to a good extent. So let's speak about work opportunities from the aircraft industry and then space industry and others. So the aircraft industry is dominated by Airbus, and everything else is set around supporting Airbus. Okay, so you have a lot of subcontractors like Akka Technologies, Capgemini, Honeywell, Collins. So what happens is Airbus does a lot of work within the company. They also decide that we will outsource some of this work to other subcontractors. Okay, and this can be anything from control system design to systems engineering to structural design, so many things. It's not just small work, and these companies do it. Apart from which, you also have a lot of small startups specializing in vertical takeoff landing systems, in drones, etc. The space industry in the European Union is not usually open to European Union residents yet, for the most part. Okay, small startups are always a possibility. The big companies in space in Europe are Ariane Space, Thales Alenia Space, and Airbus Defence and Space. So Ariane Space is a rocket company. They make the Ariane 5, the Ariane 6, and a lot of launchers. Thales Alenia Space is the company I'm working in. But keep in mind, I'm working in the UK branch. So this point still applies because I stayed in France and I could not find a job in Thales Alenia Space France, but I was able to find a job in Thales Alenia Space UK. The specific reason being post Brexit, a lot of companies in the UK um, had to relax their, let's say, had to relax their margins, and since UK is not part of the EU anymore, for them recruiting a person from France or recruiting a person from India with a French nationality or an Indian nationality does not make a huge difference, because both of them require the same kind of visa to come and work in the UK. So it makes no difference for them. So then they can focus on actual profile and talent rather than focusing on citizenship. But that is still not the case in the European Union. Some opportunities are there, but you need to work hard to find it. But you can find. Other things to think about: wind energy, Siemens and Vestas wind energy, both are based in both are based in Europe, doing really well. And then a very tangential opportunity for people who are interested in aerospace engineering and automobiles is Formula One. Formula One has so many applications from aerospace engineering. It's ridiculous. And UK is the hub of Formula One. So that's also an opportunity to think about. So to specifically mention, the aeronautical industry is trying to move towards net zero carbon emissions, which means renewable energy, green energy, and stuff of the like. So the entire aerospace industry is being geared to move towards sustainability, net zero, and stuff of the like, which means technology is also being developed to help this. So the current trend in the aeronautics industry: hydrogen powered aircraft for blended wing body design, cryogenics, and zero emission propulsion. urban air mobility to solve transportation issues, distributed propulsion. Distributed propulsion is again the main driver of distribution propulsion is to create air taxis and actually supplement urban air mobility. Okay, so that these are the like hot trends in the aeronautical industry. Usually geared, you will see that the common thing is sustainability, transportation, zero emissions, hybrid technology. You know, this becomes a recurring theme. Then behind this you have trends such as digitalization, which means how can you transfer everything that you see in terms of hardware, in terms of like say a digital mock-up, so that you can simulate things more efficiently and identify risks beforehand. Then V&V, system architecture design, etc. The space industry is also focused on sustainability. So space debris is a big issue. I'm sure all of you have read the news nowadays that there's more and more space debris. So how can we clean it? First of all, how can we monitor it? And secondly, how can we clean it? Then we have satellites that are currently in orbit that will run out of fuel, and they will essentially either stay in orbit or they will be made to burn in the atmosphere. A current trend is that instead of doing that, why don't we just send a satellite to go and refuel the other satellite, so that they can continue their activities? And that is the domain of in-orbit servicing. Okay, life cycle extension. And then the third thing is constellations. So the idea of having constellations is, instead of having huge 6,000 kilogram satellites sitting at 20,000 kilometers above the surface of the earth, we will have hundred we will have 100 satellites at 500 kilometers altitude, that weigh around 200 kilos. So then the cost of launching these satellites to space becomes almost the same, because 500 kilometers and 20,000 kilometers is a huge difference, isn't it? And the more further you are away from the surface of the earth, the more expensive the launch is. So that is the idea of constellation. So you have Starlink, you have a lot of different constellation options, not only for telecommunications but now also being developed for earth observation, etc. So a good example of that is the Copernicus mission. So in this line, startups are working on building CubeSats, and then to send these CubeSats to space, companies are now building small scale launchers that send CubeSats into space. So specific to the French aerospace industry, this is their new space ecosystem, which means these are all companies, space companies, um, that work on some aspect of the space value chain. So all of these companies do not necessarily build satellites, but then they work on in some aspect of the space industry. So for example, if you look at infrastructure, U-Space, Hemeria, E-Space, Loft Orbitals, these companies build platforms, which means satellite structures. These guys provide subsystems. So for example, TrustMe, ExoTrail, they provide electric propulsion systems. Anywaves provides antennas. Symphony GNSS provides GNSS sensors, etc. Then you have satellite services. So satellite services can be anything from providing mission software to in-orbit servicing, etc. Then you have launch companies, Venture Orbitals, Spark Orbitals, Dark, etc. And then on this side, you have the other side of the chain. So after you send a satellite into space and it collects data, what do you do with the data? So data first needs to be collected, then it needs to be analyzed. And after the analysis, you come up with different products that could help people. So there are so many layers to the entire space infrastructure that happens. So you launch, you need satellites, you build a satellite, you launch the satellite, then you collect the data, you analyze it, and you create products for people. And then finally you also have space exploration. So this slide is just a quick look at let's say the hot words in the space industry in Europe. for the next, let's say, 10 to 15 years. So take a few seconds to pause the video and look at it. So what's the situation in the US? The US has a more hands-on approach to education. Extracurriculars play an important role. Let's say it's a bit more balanced, while Europe has a bit more hardcore education system. However, the problem again is that the only way to break into the market is persistence, meaning opportunities are a bit more restricted, which means you need to try and wiggle around and find a way if you can make it into the market. So a few things to keep in mind is that the US follows a strong non-discriminatory basis approach. So one page CVs without much, let's say, decorative elements. It should be as plain as possible without your picture. And also you need to have tailored resumes and cover letters, which means for every single company you apply to, you need to convey your story as to why you are relevant to that company. And this is especially important in the US. So, like I mentioned before, you have to be a US person to get a job in the US for the most part. A lot of There are companies coming up where you will be able to find opportunities. They are far and few in between, but persistence will help you find it. If you're looking for drones and, let's say, urban air mobility, there are more options because they usually do not work with the Department of Defense, which means they are not ITAR restricted. So you need to see, and you will essentially need to work around to see what you need. And another thing to think about is jobs are highly interdisciplinary, which means that you cannot just show that that you have some core competencies, but you need to go beyond that, showing that you have capability to work in multiple fields, capability to understand things that are going on in different teams, etc. So it is highly competitive. Finally, quickly talking about systems engineering and LinkedIn. Okay, so systems engineering is not taught in colleges in India, which is understandable because it is not a technical concept. Whenever a project is run and someone wants to make something, so for example a satellite, you have engineers who will work on developing the technical solution, right, which means doing design, analysis, development, etc. But then you need people who are responsible for the project as a whole, which means how to carry the project forward from the beginning to the end throughout the entire life cycle. When do we do this design? When do we go and do this testing of these kinds of systems? How do we do the testing of these kinds of systems? Do we restrict our testing to this level or do we go higher? What are the requirements of our system? So on and so forth. So systems engineering works more on that aspect. Some people see it as more of, like, say, an admin role. Some people see it more as a management role. It is a mixture of everything, you know. But there are limited rules in systems engineering. Okay. So what you need to remember or take away is this famous diagram called the V cycle. So the V cycle explains the entire process of a project. So when if you go into a large company and if you are joining work, you will be in one of these phases: phase 0, phase 1, phase 2, phase 3. And this is the V cycle that is followed. So you have project planning, systems engineering, management planning, CONOPS, system requirements, subsystem requirements, design, and the cycle keeps going on. So you first have to design your requirements. You first design your requirements, flow requirements down from, like, say, a satellite to a subsystem. So a satellite will decide that I need to be in this orbit, I need this thrust and impulse from the thruster. Then the subsystem, which is the electric propulsion, or which can be any propulsion system, will say that okay, the thruster needs this much of thrust and this much of impulse, but how do I do it? Then in the propulsion level requirements, you will say that I need the anode current to be this much, or I need this much mass flow of xenon to make it work. So you keep refining your requirements as you go lower and lower. Then once you have reached a point of refinement, then you do the design. So a lot the engineering design work, hardcore design work, is this one: detailed design, software coding, hardware fabrication. Then after you have done the entire design, you have to do the testing. So you first test at an instrument level, then you test at a subsystem level, then you test at a system level, and then each step you go, you keep integrating. Finally, you will end up with your overall system. So a satellite, so any product, like for example, a satellite or an aircraft, is planned from the top down and then verified from the bottom up. And this cycle is known as the V cycle. And this comprises the entire life cycle. So a systems engineer's job is to complement this entire process. So it can be where it can be working on requirements, it can be working on verification and validation, or it could be working on project management, project planning, etc. So it's an interesting domain. And a systems engineer is normally aware of all these kinds of things. So traceability, gates, risk management, etc. So finally, before I wrap up this rather long presentation, for those of the few of you who have remained in this presentation, I wanted to emphasize on the power of LinkedIn. LinkedIn is an amazing platform where you get to be inspired by other people, but more importantly, it's also a platform for self-marketing, right? So try to stay active on LinkedIn. Try to put posts that are relevant to what you are interested in, and try to keep a conversation going. This helps open up opportunities. It helps you to connect with more people. You'll be able to seek advice and understand things that you would not have understood before. I found that LinkedIn always helps for me. I found a lot of opportunities through LinkedIn. And even now, a lot of people take advice, get advice on the on, let's say, the finer aspects of things from me and other people like me who have just become professionals from an educational system through LinkedIn. So this is something that I will urge all of you to pay some attention to. So yep, with this I complete my presentation. If you guys have any questions, do not hesitate to reach me out on LinkedIn,